Experienced PHP programmers know how to write fast code intuitively, and in this video I want to formalize some of the best practices I use every day based on a real-world example, the JsonLogic PHP library that I recently optimized while consulting for a Tideways customer. These best practices are meant to go beyond micro-optimization character, and I will share the preconditions that will make them useful compared to when they are not. Moin! I am Benjamin and I'm working on PHP performance topics for the last 10 years, helping thousands of developers along the way. The JsonLogic PHP library is a parser that accepts JSON-logic rules and executes them in PHP. So what are JSON-logic rules? This is a language that allows you to express a formula, either a Boolean condition or a calculation using a JSON language, and then allows you to pass in data at runtime against those formulas to compute them. So this is useful if you want to have sort of non-developers or external systems provide business logic, for example for price calculations, to an application and make sure that it's executed in a sandbox according to strict rules. So how does it work? A simple rule is always using an operator as the key of a JSON object and then the operands as an array of values. So for an equal sort of operator, you have two operands, the left side and the right side, and these are defined as two values of an array in the JSON object. So if you have this JSON formula, you can decode it and then you put it into this JsonLogic apply function to sort of get back this value. And we'll see a simple example how to use that now. After installing the library with Composer, we can write a simple test script here. So I want to implement a calculator. So I use the plus operand and two variables as operands. And then I call JsonLogic apply with this rule, and then I pass in sort of A and B as data. And I could build it in a way where this is dynamic from a product, for example, or from user input. So I can run this, JsonLogic simple PHP. So we can see the output is 3, and this is sort of my very simple calculator. The customer case was a more complex real-world scenario where the formulas were quite big and they were assigned to products as price calculation rules. And the products are extremely complex in this customer's case. They have tons of different rules, price groups, and add-ons, specific conditions, and everything. So this is represented as a complex JSON formula with which can be created by a third-party system. So for the customer's real-world use case, we had a much more complex calculation, specifically a price calculation in their e-commerce system. The products in this store were quite complex with many different variants, many different rules, and configuration ability, making it quite complex to compute the prices based on all the various inputs that the users could make. So you can see here, based on if conditions on the price group, different prices are being used. And this is quite a deep formula. Then the different prices of the product, of add-on calculations are added. The product can be assembled on site at the customer, and then based on the different price groups, there are different prices based on the assembly. And this is performed for many different products in the customer store. So we have an example data object here, and then we try to calculate this for 10,000 times. So this assembles sort of the real world example of the customer where this pricing calculation could roughly take around 400 to 600 milliseconds. And in every request that like sort of show the product. And we want to optimize this by using a profiler, looking at what we can do to improve this. So the first step is running a profiler. In this case here, I'm using the Tideways profiler, CLI. I run this. I see here that I have a trace, 606 milliseconds. I'm going to look at that. We can see in the call graph what sort of is slow in this library. So we can make out two basic functions that are called quite a lot of times. So we have this isLogic function being called 803,000 times for a total of 110 milliseconds. And then we have the apply function being called a lot of different times at different recursion levels. So if we can see here, apply is at a recursion level or recursion depth of 1. So the recursion goes quite deep here. Recursion depths of 6, we see here 7. So the way the JsonLogic library works, it recursively applies the rules based on the depth of the JSON document. Let's see how this looks in code. So we'll take a look at the JsonLogic file from the top. So we have the function isLogic that we saw before, and we have the function apply, which is sort of the entry point into this API. So let's look at what we can do and what can we optimize here. So the first thing is something I saw on the GitHub page already in the pull requests. There was an open pull request that said optimize apply by moving operators into a static array where possible. So what does this change do? We can look at the code here. The apply function defines a list of operators that we use. So the equals we saw. We also saw the plus operator in our calculator example. So where is that here? So the plus example. And what we can see is that the apply function always redefines this operators here. And because these are closures and we saw that we recursively call them, that means that every calling of sort of this apply function recursively will always reinitialize this data, even though it doesn't change from call to call. So what we can do here instead is we make sure that we have the operators initialized only once and then reuse them from this initialized state. This patch is quite complex, so I'm going to apply it as quickly as possible here. So what you can do in GitHub is to append the patch. I'm taking the patch to my local system. I store it new file JSON operators patch, and then from the command line I'm going to patch. I'm going in the library itself, JsonLogic vendor, and then I'm going to patch, and then JSON operators patch. And that succeeded. So let's take a look. Yes, so we have the build operators now. Function now, we save that. And we look at the profile to see what changed. So Tideways run, PHP, JsonLogic complex. And we can see the time reduced to 406 milliseconds And looking at the trace, so we can see again, sort of the time from its logic is still the same, around 111 milliseconds to before. I think that was, yeah, 110, so exactly. But the timings changed quite a lot here. So the 200 milliseconds are saved just by not reinitializing this operator again. This is especially powerful if you're initializing closures, which are expensive to set up in PHP. So what could be the next thing that we optimize? So we see JsonLogic is logic here. This is something we will look at a little bit later. But let's look at the call graph from the top first and see sort of like what takes time and what can we look at and improve. So we have this topmost JsonLogic apply call, and this calls a closure on line defined in line 344 60,000 times through by an array map. So there's an array map call here in between JSON apply and calling this closure. Let's look at the code a little bit. Where does this happen? So in JsonLogic, so we have on line 344, here, recursion. This is the recursive applying of the rule logic, and what it does here is it's using array map to do that, and because we call this recursively, so array map again recursively calling apply, and we saw on the call graph apply is being called up to a depth of 7. This means we have sort of a lot of array map calls here, and this is a very tight loop. I would call this the hot path of this code. And whenever you have a hot path and you are performing an iteration, then array map is actually a very bad way to do this, and it takes a lot of time because it has the function call overhead that you don't have if you make this a for each. And this is a regular performance optimization that I can see. I also saw this in Doctrine before, which I maintain. So in Doctrine we had this problem as well, where we had an array map in a very tight loop that is the hot path of Doctrine, and we modified that to become a for each loop instead, and that improved the performance massively. The same is a problem here in this library, where we have the hot path of this computation being affected, and we can improve this with the for each. The patch for this is much smaller than the previous one, so I can copy paste this here. It's I just see it's a different line actually, so there are multiple places that are doing array map. So this is the one that is the regular path in the code. So let's replace that. So I already put a patch on to make this change. For the customer consulting project, we saw a 267 millisecond drop by applying this. I'm going to replicate it and building this out manually, because it's just like changing these lines. I will for each over the values as key value, and then I will replace key with self apply value and data. So this is changing the array map to an for each. So we run the profiler again, And compared to the 400 milliseconds before, we now see 357 milliseconds. And in the core graph, we don't see the array map anymore. So we see like a 43 millisecond improvement by replacing the foreach with the array map with the foreach. So the next thing that we can see in the code, and that this is something recurring that we also talked about in previous videos, is not using compiler optimized functions, an optimization that opcache and the Zend engine provide. And this is only necessary if there are functions that are called a lot of times and they have compiler optimizations. This means the function itself is not called directly anymore, but the engine calls sort of a more optimized version of it. So we see here isArray is one case of that. Tideways even shows this, that you can rely on compiler optimizations. And the way to fix that is to use function imports. And we can see here in this example isArray, array keys, and count. Count is also a compiler optimized function. So we can import these three functions. IsObject also compiler optimized. So maybe this for functions. And then we can see how the performance fares after that. So this is a rather simple change. At the top, we can just say use function count, use function isArray, use function array keys. This one is, I think, not compile optimized, so it might not change a lot. And isObject was also one. So let's have those. We run the profiler again. We can see time now reduced quite a bit, 265. So that's an improvement. And we can see here, okay, array keys was not optimized, but we don't see the count function anymore. So we see a string, so this one can actually be optimized as well. So that shouldn't be a lot. Let's also optimize this one. Use function is string. We run the profiler again. So this optimization doesn't cause this big improvement, I believe. So it's rather a lie to some degree because of variations. If we run this more often, it would be just the 2 milliseconds we saw before. But as you can see, it's much faster than before now already. So what is the last thing that we can maybe look at optimizing? So PHP becomes slower in the number of function calls that you have. So if you have functions that are being called like a lot of times in a very tight loop in the hot paths of your application, then it might make sense to inline those functions into the code that uses it. So in this case, we still see JsonLogic getOperator and isLogic. These are called, like, this is 1 million times, 830,000 times. So this is really a lot of times, and we might benefit from inlining. So let's look at the code. GetOperator. So GetOperator is just this code here. So maybe let's just like do this. Instead, let's see if it's used in different places. isLogic also uses it, and isLogic, as you remember, is called quite a lot. Let's run again. Only 211 milliseconds, so we save more time than before. Looking at the call graph, GetOperator, the function is not being called anymore. So we have isLogic and getValues now. So let's take a look at isLogic. Where's that one called? And can we inline it? So getValues is also called a lot, but we wanted to look at isLogic now. So isLogic is quite a simple function. It checks for isArray, then if the count is 1, and if the key of the array is just 0, is a string. So where is isLogic called? In our example. So in the apply function, it's called right at the beginning. So we could inline that one here. Let's try. Because we know apply is called so often, we inline this here. And this is something that I wish PHP had or will become at some point, allowing the engine to inline functions that are pure functions. They don't have side effects, don't change state. Like if PHP could detect them and inline them, that would be awesome. And we will check what this has for an effect on the performance. So again, like the 20 milliseconds down here, looking at the call graph, we see only getValues is now mentioned as a function that takes a lot of time. So let's find out where it's called. GetValues is called from apply. So let's look at sort of the places where getValues is called. Okay, so in apply right after this. So let's see getValues. How's it defined? So it again calls get operator. So we already inlined that. And then it also checks isLogic again. But we don't see that in the call graph. So it seems for our, at least for our formula, no, it's still called quite a lot of time here. So this function, for my taste, is too big to inline because it makes it a little bit more difficult to make sure that this is the correct inlining, especially because it reuses op and values as names, which I remember are being used in the to be inline function as well. So there might be an overriding of these values. So not sure if that makes sense here. But you see my sort of like applying logic here. So I see that I have code that is run in the hot pass. I run an optimization, the profiler looking for which sort of like small pure functions are in the hot pass that I might be able to inline without making the code much more unreadable. And then I just inline them or don't based on this information. So we started at a point where our complex JsonLogic calculation took 600 milliseconds and we optimized it down to just 190 milliseconds. So it's just 33% of the original runtime. It's quite a big optimization by not doing a lot of things. So we only refactored the code. We made use of a few optimizations that good PHP programmers do automatically. So do not like reinitialize state that stays the same over and over again was the first optimization. The second optimization was in the hot pass of code, don't use array map, but use foreach. And then also in the hot pass of code, try to inline compiler optimized functions as much as possible. And then the last one in the hot path of code, inline PHP functions that you need, helper functions, inline them into the main method as well if they are called a lot of times. So let's say at a threshold of 100,000 times before thinking about inlining them. And all in all, these optimizations for our customer made up a huge, like 3-digit milliseconds optimization for their pricing calculation and made the experience for their customers much faster. If you like my content about PHP performance, please subscribe to this channel or to our newsletter. The link is in the description. Bye!